Today we are going to learn electronic, especially transistor. Transistor itself can be divided into three categories. They are MOSFET, metal oxide, field effect transistor, Johnson field effect transistor or GFET, and bipolar Johnson transistor or just called transistor. And today we are not going to learn these two kind of transistor, MOSFET and GFET. We only focus our attention on this transistor, bipolar junction transistor or transistor. A transistor is a combination of two diodes doped back to back to form one entity, like this. Transistor has three legs or pins. They are base, emitter, and collector. There are two types of bipolar junction transistor or transistor. PNP with its symbol like this. PNP configuration of the diodes. The negative is combined in the middle, such as this configuration. And PN with its symbol like this. Negative lead combine together to form one transistor, just like this. The symbol is the arrow never point in, so the arrow always pointing out, never point in. You can remember this, never point in. Transistor usually function as a switch, a gate, or amplification. In fabricating a transistor, collector pin is usually doped lower than the emitter, so its resistance reading on the ammeter, base emitter junction higher, base collector junction lower. That is why common emitter configuration most commonly used, because we are expecting to produce the highest current and power gain via the collector pin. Now let us measure transistor to determine which base, emitter, and collector, and to know bad or good condition of the transistor. Set the apo selector to diode symbol on the ammeter, like this. The pointer pointing to the diode symbol, and then put on the ammeter. First, we determine whether this transistor is NPN or PNP. This transistor is a PNP PNP type because the base is negative. PNP this pin lower reading, so this must be collector and this base, and the type of this transistor is PNP. And what about this one? This type of transistor is NPN, positive base, and the collector is this one because this is the lower reading, lower than this one. This must be emitter and this collector is base. If still doubt, try to measure its beta or HFE value. Insert the pins to the small hole respectively. If it shows a certain number, that means the pin is in correct position. So notice where the emitter, base and collector pin are. If no certain value or the reading still in 0, 0 means wrong position of the pin. So let's try it. So let's try to measure the base, the beta value or HFE value. We insert the pin into small hole, and the reading says 222. It means this transistor has amplification number of 222 milliampere. So this transistor can amplify signal to this number. This NPN and the correct position of the pin, emitter, collector, and base according to our measurement previously measurement. And let's try another transistor that we have measured before. Base, collector, and this is PNP. Base, collector, and the reading is 297. The amplification factor is 296 milliampere. If you're reading 296, that is mean its amplification factors is 290 blah 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 milliampere. The greater the value of the power, the greater the value, the greater of the transistor. In the other hand, the smaller the number of the reading here means the less power of the transistor. And what about we measure this transistor? This transistor in short condition, all pin short, so this transistor in bad condition. Thank you for the presentation. I hope you enjoy this video. Thank you again.